You're good whenever.
Like, started a suspension leave? Yeah, it's like my body is just like, yeah, I'm gonna run through a quick little thing.
Alrighty.
Okay.
Let's talk for the list.
Cars turning.
Cars turning. You guys want to go up here?
Yeah.
That's what they all say.
Who are you talking to?
That's my cat.
Yeah, basically, the first thing I tell everyone for suspension design is suspension needs to end, and we actually are just trying to make the tires do things that we want, because the tires are like touch the ground. And so like suspension design is all about tires, which is really exciting because tires are very hard to understand and nobody knows about tires, and we don't have tire data, so you can only guess.
You don't have tire data yet.
Yes.
Damn, you're ready. Damn.
How the hell did you do that?
It says what you want.
Yeah.
I can't read, so.
That's a lot of work. That's too bad.
Yeah, so this is my book.
Oh shit.
I read this front to back when I was designing the 2021 suspension.
Damn.
Car needs a turn, and I was like, our car needs a turn. So, basically, I will summarize some of the key points for this because they're important to know. So as far as vehicle dynamics, like what is our goal? Our goal is basically to optimize contact patch. So that's like where the tire is touching the ground, and to optimize the normal force. So like what pushes down on the tire. One thing worth noting is, like, do you guys remember, like, in your like high school physics class, you'll have like a block on like a surface, and it like slides along the surface, and the normal force is there, but you don't care about like the surface area of the thing interacting with the ground. That's not true for tires. So for tires, the area matters, which is kind of confusing.
That is confusing.
Because there's just like things happening that we don't understand, and rubber is weird. So that's like the first thing to know, is that it doesn't work like a normal friction problem where it's just like normal force times coefficient friction. Otherwise, you could put like the smallest tire possible and still have the same like traction.
Yeah.
Which is, we know not to be true. Like if you've ever ridden a bike with like fat tires and then got on a road bike with little narrow tires, you'll know that it's like the rolling resistance is very different, and like how it hurts the surface is very different. And then like if you look at things like big dragster cars, they have huge tires on the rear for like big traction. And then the other thing that we need to think about is the fact that tires are springs. So basically, like if I had a tire like this and I push on it with like some side force, then it's gonna like deflect in a weird way. And what that looks like is basically like this. It's like super exaggerated. So this is like the front view of the tire and how it like deflects like that. This is gonna be important. Okay, so the other thing that happens is that tires don't go in the direction that they're pointing, which is kind of weird to think about at first. So, like, basically what's happening is, like, if I took this book and I put, like, a lateral force on it and a friction force on it, then it's gonna like twist a little bit. And so that's what's happening with the tire. And that's what's referred to as a slip angle. And so basically right here we can see it like the tire is not pointing in the direction of the travel. So this is important for many different reasons, and it's what allows you to turn in the first place. Yeah, so like if you were to roll a tire forwards in a straight line and push on it with like a horizontal force, then it will, and you put like a bunch of paint marks all the way around and then rolled it, it would have this like track to the side basically, where it looks like it's kind of like sidewalking, and like this angle right here is the slip angle. Does that all make sense so far?
Yeah.
I feel like I told you this stuff before, but we're going to talk about a little bit of different stuff compared to what I talked about last time. So I actually don't like this diagram as much. So I'm going to do this one. That stuff.
I love this stuff.
So this is like what I'm talking about, where like the rubber deforms, right? It's not pointing in the direction that we're talking about. And we've got this slip angle. So how do we know what the slip angle is going to be? So like the question is, if I put like some lateral force on my tire, how do I know what the slip angle is going to be? Because if I can predict the slip angle, then I know where my tire's actually pointing, and that's going to help me steer my car, because if I can get things kind of working together to change the direction of the car, that's going to be beneficial to me. So what's kind of weird is that the slip angle is not a function of just the tire, but it's also a function of the normal force on the tire. So like how much load is the tire experiencing? So basically in general, up to a limit, there's like the tire will slip more if I put more vertical load on it. So yeah, and then also the higher the lateral force, the more the slip angle is going to be. And then if I go back to the root, yeah. So we also have this like line of peaks basically. So these are all for different normal forces. So like if I take the same tire and I put a big normal force on it, then the slip angle is going to be here for some lateral force, and then there's like a line of peaks, and that's kind of an important concept, but you don't really need to understand it. It's more just like generating a relationship between like different normal forces. That all makes sense so far? Good. All right. So next thing to think about is before we get to Ackerman geometry, which we'll probably leave for another day, we can talk about how does a car actually turn in the first place. And obviously there's some like lateral acceleration that needs to be generated in order to like move a thing around an arc. Basically the reaction force on the tires has got to be equal to that, or we don't get a turning motion, right? We just get nothing, we just get straight. So if I were to, the thing that you want to do when you think about suspension design is think about things very simply first. So if we consider first this model, we've got like a bike basically, and then as you can see, like when you increase, so in order to achieve this turning radius right here, if we were to increase the wheelbase of the vehicle, like make the car longer essentially, then what you find out is that you need more angle to turn that car at the same radius, just based on the geometry. So this was like kind of the logic between like some of the old cars in terms of like, okay, how do we make the car turn sharper? We'll just shrink the wheelbase as much as possible, and therefore that equals better turn. But that isn't the case. And that largely has to do with the center of gravity of the vehicle. So if we first consider a model, like a bike model, where the center of gravity is in the center of the vehicle, then in order to make this vehicle turn, I'm going to need like basically equal forces on the front and rear tires to make it not oversteer or understeer. So basically, I guess what I'm trying to say is the entire vehicle pivots around the center of mass. So if I add two forces, like if this is my car and I put like two forces that are of equal magnitude, then this does nothing, right? It's just there. If I put a really big force here and a small force here, then it's going to tilt this way. If I did the opposite, it would do the other thing. So if we think about that, it's kind of a weird analogy, but if we think about that in terms of a car, like, are you guys familiar with kind of like oversteer, understeer? Heard of those terms before? No? Okay. Sounds kind of familiar? Yeah. So it's literally exactly what I'm talking about. So like understeer would be the case where if I'm sitting in the car and I turn the wheels like this, and like the car just goes not in the direction, like it just keeps going straight. That's classically known as understeer. If I were to turn my wheels and the back end of the car like swings out like a drift, basically, that's oversteer. And if I were to go in exactly the direction that the tires were pointing, that's known as neutral steer. So there's like so many things that like kind of like depend on each other, so it's kind of hard to like explain it from like a starting point because they all just loop around. But basically, if we go back to this model, one thing we mentioned is that if the center of gravity is in the center of the vehicle, okay, our desired characteristic is neutral steer, which means that we want the lateral forces on these tires to be equal. Because if they're equal, then the vehicle doesn't like pivot around the center of gravity. If it's pivoting in this direction, because this force is small and this force is big, that's understeer. If it was the opposite, it's pivoting this way because this force is large and this force is small, then that's oversteer. Because now, like, you can see from the force balance, if you take a sum of the moments about the center of gravity, it's going to be rotating around that CG, and that's known as like the yaw of the vehicle, basically. So that's like one of the ideas of having like that sensor in the car is if you have it right on the center of gravity and you see that like rotation, then you would be able to measure whether your car is oversteer or understeer. But it's going to be a little more complicated than that, I know. But of course, we're going to get there. Right? Yeah. So one of the main things that, and this is kind of a side tangent, but just like from like a design perspective, if I don't understand a lot of things, but I understand this, and I know that in order to make a car that is neutral steered, I need this force to equal this force, then the easiest way to do that is by having the same tire on the front and rear, because they'll have the same characteristics, right? And if I put my center of gravity right in the center of the car, then the lateral forces that those tires experience are going to be the same. And as a result, I don't need to understand anything else that's complicated, because then the car is just neutral steer at that point, because I've eliminated the need to understand the different tire characteristics. For example, if the front tire was a different tire than the rear tire, one might have a stiffer cornering stiffness. Do you guys know what I mean by that or not?
I'm going to say no from that one.
Okay, so let's say let's think of it like a spring. If I put a spring of 70 kilonewtons on the front and 20 kilonewtons on the rear, then I know that I would need to offset my center of gravity to balance those springs, right? But the problem is I don't know what my springs are. They're just unknown springs. So if I just make the springs the same, even if I don't know what the springs are, I don't care because I know they're equal. So then I just put the CFG in the center and everything works.
Right.
So that basically what I was trying to do is like cancel out the need to understand the springs.
Yeah, but presumably then you lose some other stuff we're about to talk about?
You don't, which is why the 2021 car works so well. Because it just like the center of gravity is in the center of the car, and the tires that we use for competition are same front and rear on purpose to make it neutral steer.
Right.
And if you drive the 2021 car without the anti-roll bar, because things get complicated then, you'll quickly feel that the car is kind of oversteery, but mostly neutral. Like if you turn it and you're going around the corner, it wants to stay going around the corner. It doesn't want to slide. It doesn't want to swing the back end.
Right.
But if you slap like the 6-ply tires on the front, then you've put a stiffer spring, and now things are all weird. And you don't know what's happening, and now you have to compensate for that in other ways, which we can do, but it's less easy.
Yeah.
So,
That's a quick question.
Yeah.
Like we do this, it's a sensitive topic. What was the idea between, like behind 22, like putting it in the side? Like that wouldn't make any sense.
Like you're talking about the side by side.
Yeah.
The side by side was the car before I became suspension.
Okay. It was like, oh, so that's what it did.
So that car never got built, so we don't know whether that car turned or not. But basically what I'm saying is, so in the old philosophy, the idea was this diagram. You make the car shorter, then you need less steer angle to turn the same steering radius, right? If you make the car longer, then you need sharper steering to turn tight. But the problem with that is, in order to make the wheelbase short, the driver is what they are. You can't make the driver compartment shorter. But you can make the rear end of the car shorter by slamming all the drivetrain components and everything together and on top of each other, which is what we used to do, right? We used to put like the engine here, and then it went with a CVT up, and then a gearbox down, so that we could package all that super tightly. But what that does is it moves the CFG way to the back of the car, which, if you're really paying attention, you'll realize that that probably makes the car oversteer, except there's the problem of the fact that that puts a huge normal force on the tires on the rear end, and then you have no normal force on the front tires, so you have no brake. So it's like all kind of a balancing, if you see what I mean. Like if you put the CFG closer to the rear, then you need a smaller, you need a bigger lateral force to make it not oversteer. Let's look at that. So like this, right? Basically, the logic was not flawed, like for the 2019 car, because they said shorten the wheelbase, CFG, you need a rear car, and then now look, we need this huge force over here and a small force on the front to make it neutral steer. Does that make sense?
Yeah.
Yeah.
So why have
as you increase your normal force,
Like on that.
y of r gets bigger. So, so basically by, so this diagram, what it's showing is what the forces would need to be in order to make this car neutral steer. Okay? If we put the C of G near the back of the car, then that doesn't necessarily suggest that y of r is going to be of this magnitude.
Yeah, which is gonna be weird.
It's going to be bigger than YF. But basically the problem that we have is that because the C of G is so heavy over here, then we have no normal force on the front tires, so we can't generate any YF.
Yeah.
So in that case, then you just have understeer because now you've got no force, you can't balance it, right? Like the back end of the car is going to win over the front end of the car. So I guess this whole conversation leads to the point that, again, it comes back to that first question. You know, what we're trying to do is we're trying to control the tire's behavior on the ground. So can we increase the normal force on the tires we want to in order to gain the characteristics that we want? Okay. So yeah, basically we changed the car philosophy to be, okay, let's scrap that idea and let's make the CFG in the center so then we can eliminate the need for understanding the tires, and then we can just use the tools that we have to make the car oversteer much more effectively without using the tools to try to counteract the fact that we have this huge lateral force on the rear tire already. So that's kind of like the spiel about tires.
Yeah.
Hopefully that made some sense. If you want to talk about more things, I can tell you about the tools we have to make the normal forces.
I mean, I'm kind of curious. I'm invested.
Yeah, so hopefully this all makes sense now. Let's see.
Are you just struggling to look, or do you have a question? You're squinting your eyes.
A little bit. I'm like, so we ditched still like make wheelbase shorter philosophy for like the center of gravity.
Yeah. But basically the idea is if the center of gravity is in the center of
Yeah, that
and the tires are the same tires front and rear,
then the normal force or like then the lateral forces would be the same.
then in order to make the car neutral steer, you just need equivalent forces on. Let me put it this way: the y, like the YF and the YR,
Yeah.
are not a result necessarily of the center of gravity's location. All we're saying is that in order for the car to be neutral steer, we need them to be equal.
Right.
Does that make sense?
Yeah.
So I'm not necessarily saying by putting the CFG somewhere that we're going to have some lateral forces. I'm saying that in order for it to be
Yeah. So you don't have to like understand all that weird like sort of math gymnastics. You just have to make them equal somehow.
So,
well, yeah, exactly. Like if
Yeah.
you just make the equation more, like if you make it so you can cancel things, then you don't
Yeah.
care. They cancel each other.
Yeah.
so how do you make those forces equal? How do you control those forces?
So that's the next thing.
That's cool.
So how do we control these forces? So basically, this is, so now we're moving away from just a two-wheel model and we're moving into a four-wheel model, because that's what we've done. And the forces acting on our car are obviously the weight and the force this way from the centrifugal acceleration. And basically, if the car wasn't turning, then we would have equal weight left and right. Correct? Everyone agrees with that? Okay. And if our C of G is in the center and nothing is happening to our car, we also have equal normal force on all four tires.
Yes.
Now, this is where things get a little bit weird. So we have these things called roll centers in vehicle dynamics, which is basically like the point at which all of the unsprung mass in the car pivots around. So, like, have you guys ever seen someone in the shop like pulling on the car from the side and it like kind of like will like tilt? Yeah. So basically, if you were to look at that, if you were to like take a like image of that and take it like happening and then superimpose that on the CAD, you could actually draw the lines, and then there's an axis at which the car is rotating about. So like that point on the car has no left or right movement, no up or down movement, only rotation.
So that's like the origin if we were to apply polar coordinate rotation and stuff like that. You know what I mean?
Yeah.
Same distance away, but
Yeah. So knowing that, why is this relevant? So this roll center here is, again, like I said, where the geometry is going to pivot around. And the roll center is defined by an intersection of various linkages. So like on our car for the front suspension, we use double wishbones, like the A-arms. Are you guys kind of familiar with the A-arms? A little bit.
they go like this. The tires here, the car's here, and they go A. And then they kind of stay below it.
Okay.
Let's see that.
Things that connect to the tire.
Yeah.
Okay.
I know what,
The bolts.
I don't know how much about.
If they're in the
Something
shape of
like-
an A,
it looks pretty normal.
no, not the thing that goes up and down. That's the shock. The A arm is the thing that the spring connects to, which then connects to the tire.
Oh, yeah.
It's in the shape of an
I think
A.
I know what they are.
David's pulling it up.
Okay. So like these are our ARMs.
Right, okay.
Oh, those are
Yeah.
Oh wait, David, can I just see?
Like these guys here.
Okay, yeah, that's what I thought. Okay, awesome.
You've
No,
been
those-
working in the AR for the past 4 weeks.
So,
Yeah, no, like, there's
so those make basically like it's shown here how you would draw it. Basically, you would draw like a line here and a line here, and then you draw that to the center of the tire where they intersect, and then you do the same for the other, and then where they intersect in the middle is your roll center.
Right.
That's very fancy. I don't do this math. That's one of the things Lotus does for you, is it tells you where your roll center is based on what geometry you have in the software. And so the reason the roll center is important is because if you have your center of gravity, basically this will act with whatever force is required for the like lateral acceleration, and then if you multiply that by the distance between the roll center, it basically acts as a moment, like rotating about that roll center. And then the only way to counteract that is with a force from the tire to stop the thing from like rotating, right? So now we've got this distance times this distance equal to this times this. And if, I hate that I'm saying this, because I hate but if you were to imagine like that, the best way to imagine things is like the limit. So what happens at the like limit scenario where like this force is 0,
Which force?
like the force acting on this tire is 0, then this force times this distance has got to be equal to that. And if it's any more than that, your car flips.
Yeah.
So that's
Wait,
fun.
sorry.
Yeah, you don't know.
So when you say like so if the like force on the right tire is 0, you're saying like if the left, or saying like if the left and bottom is times more, like is equal to more.
I'm saying if this force right here is
Yeah.
is 0, then this must be equal to this in order, or, yeah, hang on, just gonna mess it. Like this distance right here,
Yeah. Times that
this force must be equal to this force
So-
times this distance. Otherwise,
The car rolls.
you have rotation,
Yeah.
which means your car is
Yeah.
Good.
going up on one wheel.
Yep.
Goodbye.
Maybe it's on purpose. That's how you do some of the new cars where you're like, it's like, you know, two-wheel driving around the corner.
Yeah. So if you look at the 2021 car, you'll notice that the track width is the limit of the rules, like as wide as you can go. Another reason for that is our old car used to flip all the time, and just based on this diagram, you can solve that problem by just putting the tires further away from the center of the wheel,
Yeah.
which works.
Crazy.
Okay, so now let's talk about, this is 2D, but what if we had like, what if we had like two roll centers, right? So like the front suspension is defined by the front roll center is defined by the front suspension, and the rear roll center is defined by the rear suspension. So how can we use that to our advantage? Like, I know based on the fact that I want as much force here as possible and as little force here as possible, because I want to induce oversteer, essentially. Like we said, we want a neutral steer car, but I've already established that my car is most likely going to be in the neutral steer territory. But if I want to make it a bit oversteer because that's better for Baja, then what should I do?
You quizzing us?
Yeah.
What should you? Oh, fuck. Come on, guys, what should we do? I don't know, I'm not like you figure it out.
Yeah, so we want, the relationship between this is dictated by what? It's dictated by the normal force.
Yeah.
It's on the tire.
I knew that. I was gonna say it.
Is that right?
Yeah. So,
Yeah, totally.
so if this is dictated by the normal force, and I can have bigger lateral force by bigger normal force, what do I want to do? I want to increase the normal force on these tires and decrease the normal force on these tires.
Okay.
So how could I do that?
Well, I would just say you can shift the weight forward on the car, but that was wrong.
That doesn't work.
The tires roll center on
Go
the back.
Oh, there's this one guy right here.
Is that back?
That is math.
Cool.
So yeah, so if you put if we said, if this is our car, and this is our COG up here,
So go.
and this is the front, this is the rear.
Wow.
Damn.
Beetle.
That's the first 30 pages of the book.
So what we could do is we could put our rear roll center up here, and then we get what we call a roll axis.
Oh.
And if you'll notice, the distance between here and here is much shorter than here and here. So if I have the same, I don't have a choice, I have the same force acting on COG.
Yeah.
But if I multiply it by a smaller distance, then I get a smaller moment, which means I get a smaller normal force on my rear tire and a bigger normal force on my front tire. And I get more traction from my front tire than my rear tire. Now I've oversteered.
Nice.
How do you, like, what do you actually do to
It's a nice
change the height of this?
So, in order to change the height of these,
Is that based on your,
yeah, so like I wanted to change like the height of this, then basically like if I drag one of these A arms to point like this direction, then like this is gonna be way further out, and then it changes the height. basically.
So can you rewind like 5 seconds to that A-arm explanation?
What's that?
Like just how you changed the A-arms to make it like.
Yeah, so like basically like the we're kind of here to limit.
Okay.
Let's do it this way. Let's say I moved this arrow point to be like that,
Okay, so like a little bit down.
a little bit down. Then that line would come here, basically. It would intersect
Oh, right.
at this point, and then if I draw a point like here, and then I copy that, and like most likely what I'm gonna have is essentially that kind of like that. You get the gist.
Yeah.
So then like the roll center position is gonna move slightly.
Right, because the like that sort of first intersection line is like closer to the center. But
Yeah.
Okay.
Yeah.
Awesome.
So this is all like this is the extent of what you can do on paper. At this point, your understanding would be strong enough that you would go into the software and start playing with the points to change the roll centers instead of trying to do it by hand because you want to still figure out what it is on the points. So yeah, that's basically the whole story by that. So if you look at some of our roll cars, it's kind of like this is not roasting them, but they just didn't know. But our roll centers were actually reversed. So basically, whenever the car would roll, you're generating a huge load on your outside rear tire and no load on your front tire. And then you would basically like just kind of always do no load on the front tire. I'm trying to think if there's anything else that can tie in. It's not like another half-hour thing. Oh yeah, I guess we can talk about quickly like what. So this is all. Everything we've talked about is already built into the car. But like there's some things we can change in the car to change the characteristics of the car, like out in the field once we're like there. One of the things we can do is we can add an anti-roll bar to the rear of the car. Now, the reason that's good is because basically it will, it's kind of weird. It's kind of weird to understand. Like, basically what it does for us, it makes it so that the suspension links aren't independent. So when one compresses, the other has to compress. And if you think about that, if the car rolls, like let's say I'm turning this way, if the car rolls, then this suspension's got to compress, right? But I just said these are connected. So this has also got to compress, which means that I'm like actively lifting that inside tire, basically. So I'm like reducing the normal force on the inside tire, which means like this guy is contributing less to, or like has less normal force, which means has less force to last level force. Another thing we can do is oftentimes you'll see suspension like changing the springs.
Sorry, quick question.
Yeah.
Where does the anti-roll bar go?
So the anti-roll bar goes.
Also, it's called anti-roll bar because it's like roll like this way. That like roll
Yeah.
the jaw, whatever.
Yeah, it's,
That one.
I haven't really quite wrapped my mind around it. Like, I don't understand how it works for a road car, but I know that's how it works for us.
Oh, well.
Basically. This is it right here. It's not attached right now, but it's like, just like, it normally would be here and then attached to this. But we only do that for maneuverability because we're trying to induce oversteer.
Yeah.
But for the race, you want neutral steer, so we don't need it.
Yeah, that makes sense.
Yes, this is the energy roller right here. And it attaches to like this suspension. thing you guys will see suspension doing often. You ever seen us like reefing away on those springs, like kind of. So basically, what that does is, if I make the spring rate in the back stiffer, then it takes more weight to compress it, which means that it's essentially going to lift the rear of the car. And if I lift the rear of the car, like this whole situation gets like more extreme, and the CFG doesn't pivot like quite the same as, it's kind of like weird to imagine, but when you like lift the rear of the car, the CFG doesn't exactly like lift the same amount. It kind of pivots a little bit, and that can help us generate some more less normal force on the right side tires. Also, there's another couple things like, so it's kind of interesting. Like one thing that you will hear, like the design judges when they talk to the suspension team in the design presentation, if they don't think they understand the vehicle dynamics, the question that you will hear them ask every time is, have you ever experimented with tire pressures? And the reason is because if the answer is no, then you just don't know what to do. Because at the start I said that the contact patch dictates how much lateral force you can generate. And if you flatten your tire, you contact the ground more, which means you can generate more lateral force. So like at Laval, for example, when we did that maneuverability run, I pumped up rear tires up to like 15 psi, so that they're like barely touching the ground. And then the front tires I deflated to like 2 psi, so they got this like huge patch on the ground, right? They have like infinite traction, and like part of the reason I did that is because I knew that the car wouldn't be like, it's kind of like, it's very hard to have like a 2 oversteer Baja.
Yeah.
Like, we did, but like it's still controllable. But that's why if you like watch on the straights, the steering wheel's going like this because it's just like you're just counter steering every time.
Right. But it helps you get that grip at the end of it.
Yeah, exactly.
Yeah.
Which is what we need.
Oh yeah, and then one more. So this will be the last thing. I don't like this. I swear. I can talk about suspension drivers. Okay. What if?
Another quiz, guys.
Let's say we had like.
David Owens approved.
Now I gotta make my next move wisely.
Put 2 tires on the car.
That's a big tire.
I would say 2.
Okay.
Probably the terrible person.
What if I told you that, remember this like first image? Oh wait, it's not this. Remember the first image I showed you, the tire? It kind of looked like this.
Yeah.
Yes, sir.
Okay. What can you tell me about the area that touches the ground in this case?
Very little.
He's got bad angles.
Yeah. So one of the things we can do is like we can camber the tires in order to, so if we put a lateral force on this tire, it's going to deflect like this, basically. And the area that it's touching the ground is ultimately going to be less. So one of the things that you can do is you can tilt the tire, you can bias it. This is like extreme. So that when I apply this lateral force, what happens is like what happens is like this will become straight up and down, and the contact patch will maximize. So if you look at like an F1 car, for example, you'll notice in the front there's like
You went in the hole.
oh, I went in the hole. God, they're like slightly cambered out, so when they go around a corner, the outside tire, you'll notice, is actually standing like perfectly straight up and down, and the patch is like perfectly flat.
Cool.
And so this was one of the ideas I had.
Sorry, David, you said like in F1 Carter, like out as in like cambered this,
They're cambered like-
cambered this way. Right, okay, that makes sense.
Which leads to my next idea that I had one night. I was like, how can we make the car oversteer more? And then I realized, well, if you just do the opposite of this, which is to tilt the tire like this in its normal speed, then you're already at a point where there's like very little contact patch. And you apply a lateral force to it, and then it's like barely hanging on to the ground now.
Yeah.
So, unfortunately, doing this is essentially a crutch, because if you run your tire like this, then your contact patch is not maximized at your static position, which means you can't accelerate as fast because you don't have as much. So it's kind of a compromise. But that means, so that's why like suspension setup actually like, should matter in competition. Like if we really cared about things, we would put the rear tires so there's zero camber for the acceleration run, and then for maneuverability run, we would take that inside camber link and pull them in so that it generates like So like that's one of the things you can change like on Saturdays. Like if a car not oversteering enough, pull that bottom camber link in a little bit. It'll decrease the acceleration just a hair. But for maneuverability, you don't care about that because your cones are worth 2 seconds.
Yeah.
So you miss all the cones. You don't care how fast you are. Like for our 2021 maneuverability run, we came in third because we hit no cones. We were actually like the 10th fastest team.
Right.
So yeah, and then to further my point that people actually do this, I go random.
Oh boy.
And this is why I like suspension so much, is because we can look at other people's car and like, we're like, oh yeah, I see what you're doing there.
Yep.
I see,
Yep.
I see.
That?
Oh.
Oh, it got
Oh,
groovy
that's
legs.
crazy.
Just pretty crazy.
That is crazy.
It's also a sick render.
You don't see it until it turns around.
And this car is disgusting. Like it's so good. Yeah.
Which team is that?
RIT.
RIT.
And you can even see it in pictures like this, right? Like you see how the tire is looking out like that?
Oh.
Nice.
Yep.
Okay. And that is all. So for Saturday, things we can do, we can change the camber on the rear of the car. Unfortunately, the camber is locked in the front, and you should think about that when you see the 23 car. It's just a thought. And by camber, I mean how much is the tire tilted. So when you see the 2023 car again, just look at that and ask yourself, is that a good idea?
Okay.
Feels
like she's being thrown crazy.
No, it's actually a manufacturing problem.
Really?
Yeah.
Oh. Okay.
It's actually sorry. It's actually what?
It's a manufacturing
Oh.
problem. Which is why the car did a lot better at Wisconsin in maneuverability compared to Oregon. That's it. If you know how.
Right. Yes.
Yeah.
It didn't go well. That's what happened. It didn't turn well.
Yeah, I'm
Like
trying to think.
they didn't do well at Oregon.
Oh, okay.
It didn't do well.
Last thing I will say, are you guys planning on coming outside? I promise the last thing, because I'm going to talk about
I'm coming
actual
out.
drivers.
I'm
Usually coming out.
Mike?
You agree?
Might come out later.
Maybe?
I think.
Yes?
Yeah.
Coming.
Very hungover,
Probably.
so that's why.
Probably not.
That's the only reason.
Yeah.
You got 5 more
Next
people coming
Wednesday,
out.
school is over.
I'm
Right,
right.
yeah, we're done.
That's why I don't know how early I'll be.
No worries. Okay, so some general driving tips for driving maneuverability events. Look where you want to fucking go is a big one. People like don't do that for some reason.
Really?
Yeah.
I feel like that's like 101 of like.
Of driving. You would think, but I guarantee you watch people on Saturday, look where they're looking, and you'll be like, you're not looking, you're looking like not.
Think you're trying to.
Yeah. Yeah. Either they're looking at a thing they're trying to miss, or the classic Baja move is what people do is they'll be trying to go between two cones like this, and they'll be turning, and what they'll do is they'll start to understeer a little bit, and then they start looking to the outside of the car to see if they're going to make it, rather than just looking this way.
It doesn't matter at that point if you make it or not. If you're not making it, you're not making it.
You're either going to make it or you're not going to make it, but there's no point in watching to see whether you make it.
Yeah.
Your face
Just
is
like
already
pedestrian.
and the chances that your brain might correct it with the throttle or the brake or whatever, like, is higher if you're still looking where you want.
Yeah.
The second thing is course inspections are like this is me talking about like from my ski racing days. Like it depends how much you care about this. This will sound absurdly ridiculous to you if you don't care that much. Or if you do care about it, then you'll take it seriously. Some people think it's taking it a little too seriously. But like when you learn to ski race, you learn to inspect the course, memorize the course, measure the course, so you can like know what things feel like ahead of time. Like if I know that the spacing is 5 paces between these cones, then I know what that feels like.
Yeah.
And then like usually what I will do is I will walk through the course, I will memorize it, I will walk through the course again, I'll memorize it, and I'll walk through the course a third time, I'll memorize it, and then I'll go back and I'll like essentially visualize what that would look like and feel like to drive that course.
Yeah.
And like go through all the turns in my head, like okay, left turn here, right turn here, you know, and like that visualization really helps.
100%.
And like a lot of people think it's corny and ridiculous, but it actually does work.
I'm following you up on this. Visualization can help you do anything. It's crazy.
Yeah, like
Yeah.
That's how I learned to skate. That's how I learned to snowboard. That's how I learned to surf. All of these things. The first time, before I did it, I spent like, just like, I don't know, following up to like the week while I'm excited. I'm like going to sleep and I'm just visualizing it. I'm like, oh, this is how my body's gonna turn when I'm doing it. This is like what edges are gonna hit this ice. This is how like I'm gonna go like it. Thinking about every minute detail. Yeah, like when I skated for the first time in like 10 years. And these guys were like, oh, you're going to fall over. And then we had like a bet that I had to take a shot if I fell over, and they'd do it if I didn't. They pussied out, and they never took the shot. But anyways, it helps so much. It's crazy. You can learn so much by just visualizing it over and over and over. And it actually like helps you think about what your arms are going to be doing as you're turning the wheel, about how the car looks, about like every minute detail helps.
Yep. Okay, and then the final thing is, this is like a ski racing thing again. Like all my experience is ski racing. I never drove cars before. I don't know how to drive a car. Basically, there's a difference in a race car line and a ski racer's line. And a race car driver's line is like, the idea is to always hit the apex. So like, you want to like make it the shortest distance possible, basically, by going around the cones. And like this would be your apex. But the problem with this in a very tight maneuverability course is if you get late, then you're basically screwed. So like what I mean by that is like, let's say in this corner you end up like a little bit further down here than you want it, then you're a little bit further down here, and then now you're screwed. So basically, like the thing to do for maneuverability courses is to turn high and underneath things. So like what you want to do is you put your apex like out over here and cut like almost, if you imagine, like underneath the turns, and that really helps to like set your car up to be able to make it through like the tight slaloms.
We call that wide and tight in sailing racing.
Why are you cutting what racing?
Sailing racing.
Sailing racing.
Oh.
Wide and tight.
Wide and tight.
Sailing racing?
Yeah. I
That's
tried to
cool.
join the team here, but they've got.
Could we have a team?
It is a team.
There's like a
Absolutely.
That's so sick.
But next year, if the sailing team is running, then you can also have sailing.
I would love
That's
to
so
come
sick.
down.
I'm so down.
Let me know if you ever go on this sometime in the summer. I'll join
Oh
you.
my
I'm
God.
so down.
Yeah, I don't, well, I do own a boat now.
What
You
the
own a
fuck?
boat.
I didn't
I
have a
forgot
boat.
you
You're
bought a
Davis
boat.
guy owns a
I
boat.
acquired a boat recently.
You acquired.
Acquired means stolen. It was a suspicious hire.